Hi, my name is Meeta Kumar, and I am here to discuss the last of our modules on consumer theory. In the preceding modules in this set, we explored the notion of a consumer's equilibrium. In this module, we shall explore the concept of demand. We start with a recap of the consumer's equilibrium discussed in earlier modules. The consumer's equilibrium describes how much of each commodity a consumer will buy given the following: A. Prices of commodities, B. The consumer's income, and C. The tastes and preferences of the consumer as described by his indifference curves. The theory of demand explores how the quantity consumed changes when any of these parameters change. So let us recap the consumer's equilibrium. We combine what we know about the budget sets and indifference curves to figure out what the consumer consumes and in what quantities. The diagram shown reproduces the budget set discussed in an earlier module, and we assume that the two consumers that the consumer is choosing between are, as before, books and movie tickets. Remember, we do this only as a simplification. You can choose any two commodities you like. In principle, you can also extend this analysis to more than two commodities, but that would just make our diagrams extremely complicated. The budget set represents what the consumer can afford to buy given a certain income, which we assume is rupees 2,000, and the prices of commodities, which are rupees 50 a movie and rupees 100 a book. Superimposed on this is a consumer's indifference map. This represents the consumer's preferences. The consumer will try to achieve the highest level of satisfaction he can achieve given his budget and the prices of commodities. Notice that the highest possible indifference curve that the consumer can reach is the one that just touches or is tangent to the budget line. This occurs at the point E, where the consumer is consuming 16 movies and 12 books in the diagram shown here. This is the consumer's equilibrium. At E, his utility is maximum, given his incomes and given the prices of the movies and books. The consumer can do no better than this and has no incentive to change unless prices change or his income changes. At E, the slope of the budget line equals the slope of the indifference curves. Recall that the slope of the budget line is the ratio of prices of the commodity on the x-axis to that on the y-axis, and the slope of the indifference curve is the marginal rate of substitution. Thus, at equilibrium, the marginal rate of substitution between x and y equals the ratio of px to py. In our example, the marginal rate of substitution for books is equal to the price of movies divided by the price of books, which is equal to rupees 50 divided by rupees 100, which is half. This answers the basic question of what does our consumer buy? Our consumer buys books and movies. In what quantities? He buys 16 movies and 12 books. What happens if the price of movies changes? Suppose the price of movies goes up to rupees 100. We saw in the previous model how the budget line changes. This is depicted in figure 2 shown here. Superimposed on the budget lines is the consumer's indifference map. The consumer's old equilibrium, E1, is now beyond his new green budget line. He cannot afford it anymore. His new equilibrium is where his new budget line is tangent to the highest possible indifference curve, and this is at E2. He now consumes only 10 movies and 10 books rather than 16 movies and 12 books that he was doing earlier. Notice that the number of movies consumed has gone down as the price of movies has gone up. What would happen if the consumer's income had gone up? Recall that an increase in income keeps prices unchanged, and this causes the consumer's budget line to shift out parallel to the original budget line. The consumer would therefore move to a new equilibrium described by where an indifference curve touches his new budget line. In figure 3 shown here, the consumer's income has gone up from rupees 2000 to rupees 2500, and the prices of movies and books have not changed. At the new equilibrium, the consumer consumes 15 books and 20 movies. We use the above analysis to understand what determines how much of a particular commodity the consumer is buying given her preferences and given the prices of commodities and her income. With this, we can now explore the idea of demand. The demand for a commodity is the quantity of that commodity that a consumer purchases given her preferences, prices, and her income. There are two aspects of demand that are useful to remember. First, demand reflects the amount of the commodity a consumer wants to buy. Her want is captured by her indifference map. Second, she has to be able to afford it, and this is captured by her budget line. Let us list the determinants of the demand for a commodity. These are A, price of the commodity, B, prices of other commodities, and C, the consumer's income, and D, preferences of the consumer. A mathematical representation of this relationship is called a demand function. A general representation of a demand function is this: Qx is a function of Px, Py, M, and T, where Qx is the demand for the commodity X, Px is the price of the commodity X, Py is the price of other commodities, which might be Y. There may be, of course, more than one commodity. M is the consumer's income, and T is the consumer's tastes or preferences. Let us explore the effect of a price change on demand. So, if the price of the commodity changes, our analysis of consumers' equilibrium allows us to predict how demand changes when any of these variables change. In order to achieve clarity on the matter, economists use a strategy to change only one variable at a time, keeping all other variables unchanged. We have already seen in the above example that when the price of movies increases, other things remaining the same, the consumption of movies went down. In other words, when the price of a commodity increases, we expect the demand for that commodity to go down, other things remaining the same. Conversely, when the price of a commodity decreases, we expect the demand of the commodity to go up, other things remaining the same. So, the price of a commodity and its demand are said to be inversely related. What do we mean when we say other things remaining the same? We mean that we are keeping other prices, income, tastes and preferences unchanged. The Latin phrase ceteris paribus is often used to denote this. The graphical representation of a demand function is called a demand curve. While drawing the demand curve, price is measured on the y-axis, while quantity is measured on the x-axis. The demand curve is downward sloping, displaying the inverse relationship between the price of a commodity and its quantity demanded. Figure shows the demand curve displaying this inverse relationship between price and quantity of the good. The law of demand states that usually a consumer's demand for a good is inversely related to the price of the good. We can illustrate this with a linear demand function, which would simplify and help us understand the idea of demand. A linear demand function can be written as QP equals A minus BP when prices are in the range of 0 to A divided by B, and equals 0 when prices are equal to or are greater than A divided by B. Here, QP denotes demand of a commodity as a function of the price of the commodity. You will recognize the first part of this function as the equation for a straight line. On the x-axis, we have the quantity demanded of the good, and on the y-axis, we have the price of the good. Our x-intercept here is A, while A divided by B is our y-intercept. The slope of the curve measures how much the quantity demanded changes following a change in the price of the good. The slope of this function measures how much the quantity demanded changes following a change in the price of goods. The slope here is minus b. The minus sign denotes the inverse relationship between quantity and price, which suggests that for each unit increase in the price of the good, the quantity of the good demanded falls by b units. We have chosen to ignore the other determinants of demand for simplicity's sake. Figure given here depicts this linear demand function. The demand for a commodity may also be related to prices of other commodities, depending on whether they are complements or they are substitutes. Commodities which can be consumed in place of each other are called substitutes. Tea and coffee are substitutes for most people. Sugar and jaggery or gur are also substitutes. If the price of coffee goes up, what happens to the demand for tea? Typically, the demand for tea will go up because consumers will switch from coffee to tea. Commodities which are consumed together are called complements. Tea and sugar, for example, are complements. If the price of sugar goes up, what would happen to the demand for tea? People who like their tea sweet may actually cut back on their consumption of tea. The demand for a commodity usually moves in the direction of the movement of the price of its substitutes. If the price of the substitute increases, the demand for the commodity also goes up, and vice versa. The demand for a commodity moves in the opposite direction of the movement of the price of its complements. If the price of the complement increases, the demand for the commodity will fall, and vice versa. Typically, when a consumer's income increases, the demand for commodities will increase. If the consumer's demand moves in the same direction as the change in his income, the commodity is said to be a normal commodity. So, for a normal commodity, its demand would go up with the rise in consumer's income and fall with a fall in income. If a consumer's demand of the commodity moves opposite to the direction of the change in income, the commodity is said to be an inferior commodity. So, for an inferior commodity, its demand would go up when the consumer's income falls, and its demand would go down when his income goes up. Usually, these are commodities that are consumed at very low levels of income. For example, people tend to consume more food grains at low levels of income. As incomes rise, they consume less food grain and switch to quote unquote better foods such as milk, fruit, and vegetables. We now turn to movements and shifts in the demand curve. The demand curve, which we drew in figures 4 and 5, were drawn with the assumption that other things remain unchanged. Each point on the demand curve indicates the quantity that one would purchase at a particular price. So, for changes in the price of the commodity, ceteris paribus, you move along the demand curve. This is referred to as a change in the quantity demanded for a change in price. A downward movement along the curve shows an increase in the quantity demanded and is called an expansion of demand. An upward movement along the curve shows a decrease in the quantity demanded and is called a contraction of demand. But if any factor other than the price of the commodity changes, then there is a shift in the demand curve. This is referred to as a change in demand. So, a change in income of the consumer, or the tastes and preferences of the consumer, or the prices of other commodities would shift the demand curve of the commodity. A rightward shift shows an increase in demand of the commodity, while a leftward shift shows a decrease in demand for the commodity. Figure 6 depicts these shifts. So far, we have focused on the individual's demand. Let us now turn to the market demand. Market demand for a commodity at any price is the sum of individual consumer demands at that price taken together. Graphically, the market demand curve is derived by horizontally adding the individual demands from each demand curve. Assuming that there are only two consumers in the market and the price is P prime, the demand of the first consumer is Q1 prime and that of the second consumer is Q2 prime. So, the market demand for the commodity at P prime is the sum of individual demands at that price, which is Q1 prime plus Q2 prime. Similarly, at a different price, say P hat, the first consumer has the demand Q1 hat and the second consumer has the demand Q2 hat. So that the market demand for the commodity at P hat is the sum of individual consumer demands, which is Q1 hat plus Q2 hat. Thus, the market demand for a commodity at all prices can be derived by adding up the demands of the two consumers at all those prices. We carry the same exercise out even if there are more than two consumers. Figure reproduces this discussion graphically. The rightmost graph is the resulting market demand curve from the horizontal summation of the first two individual demand curves. We can now turn our attention to the concept of elasticity of demand. Recall that minus B was the slope of the linear demand curve, which we discussed earlier. This told us how much the quantity demanded of a commodity changed if the price of the commodity changed. We introduced here price elasticity of demand as a formal measure of responsiveness of demand to price changes. It is defined as a percentage change in the quantity demanded of a commodity divided by the percentage change in the price of the commodity. We denote this by E subscript D, where E subscript D equals percentage change of the quantity demanded of the commodity divided by percentage change in the price of the commodity. Since both numerator and denominator are in percentage terms, the price elasticity of demand is a pure number devoid of any units. We can rewrite the above formula for elasticity as shown here in equation 1. The numerator on the right hand side of this equation is nothing but the percentage change in quantity demanded. The denominator is the percentage change in price. The subscript 1 denotes the final value of the corresponding variable, and the subscript 0 denotes the initial value of that variable. Remember, change is always measured in terms of final value minus initial value. The price elasticity of demand bears a negative sign because of the inverse relationship between the price of the commodity and its quantity demanded. We often focus on the absolute value of elasticity denoted by the modulus of ED. When the modulus of ED is greater than 1, the demand for that commodity is said to be price elastic. If the modulus is less than 1, the demand for that commodity is said to be inelastic. If the modulus is equal to 1, then the demand for that commodity is said to be unitary elastic at that price. Generally speaking, a flatter demand curve is said to be more elastic than a steeper demand curve, provided both the curves are drawn to the same scale, because a flatter demand curve shows a greater change in the quantity demanded for each unit change in price at a given price level. Thus, the absolute value of ED would be higher in case of the flatter demand curve than in a steeper demand curve. Let us look at the price elasticity of a linear demand curve. As we noted earlier, we have a linear demand function in the form QP equals A minus BP. We now present equation 1 in a slightly altered manner. Recall that for a straight line demand curve, the slope is minus B. So we use the above expression in equation 2 and obtain equation 3. All that we have done here is to substitute minus B for the slope, which is change in quantity divided by change in price, in the first term. In the second term, we have substituted the value of Q from the equation of the straight line. We now have elasticity as a function of price alone. So, we can predict that for a demand curve which has the form QP equals A minus BP, the elasticity of demand will vary across points on the linear demand function according to equation 3. The table presented here shows the elasticity for various prices observed for this demand function. The diagram that follows depicts the same graphically. So, what is ED when Q equals 0? You can see from equation 3 that it will be minus BP divided by 0, which is infinity. When a linear demand curve is drawn, it is easy to calculate elasticity at any point on it. Without giving the proof of this, we can tell you that the absolute value of elasticity at any point E on the demand curve is equal to the ratio of the length of the line segment which joins E to the x-axis to that of the line segment which joins E to the y-axis. We illustrate the same via a diagram. Assume point E anywhere on this demand curve. The price elasticity of demand at the point E is given by a ratio of the length of the line segment EQM to the length of the line segment ES. Let us now turn to some additional topics in elasticity. Elasticity associated with a demand function at various points can assume values ranging from 0 to infinity. However, it may also happen that elasticity remains constant for all prices. A vertical demand curve, for example, will always have elasticity equal to 0. No matter what the price, the quantity demanded does not change. A horizontal demand curve, on the other hand, will always have elasticity equal to infinity. A curve with elasticity equal to infinity is said to be perfectly elastic, while one with elasticity that is 0 is said to be perfectly inelastic. We can also have a curve which is called a rectangular hyperbola, which has a constant elasticity of 1. The diagram here shows two demand curves which have constant elasticity. The first one is a vertical demand curve that we've discussed already. The second is a rectangular hyperbola. A rectangular hyperbola generally represented in the form of x into y equals k, where k is a non-zero constant. In our case, this becomes P into Q equals K is the expenditure by any consumer on any commodity. So, this essentially means that the consumer keeps her expenditure on this commodity constant at some value K. When the price increases, the consumer decreases quantity purchased by exactly the same proportion as the price has increased. In general, the expenditure on a commodity depends on the price of the commodity and the quantity demanded. So, as we've just mentioned, expenditure equals price into quantity demanded. Following a price change, the expenditure on a commodity may actually go up or go down or may not change at all. This depends on how the quantity demanded responds to changes in price. In other words, it depends on the elasticity of demand. When the demand is elastic and there is an increase in the price of the commodity, the quantity demanded falls more than proportionately and the total expenditure declines. When the demand is inelastic and there is an increase in the price of the commodity, the quantity demanded actually falls less than proportionately. So, total expenditure goes up. When the demand is unitary elastic, a rise in the price of the commodity causes a fall in the quantity demanded in equal proportion. So, the total expenditure remains constant. What are the factors affecting elasticity? Price elasticity of demand of a commodity depends on the nature of the commodity, of course, on the availability of substitutes, on the time horizon under consideration. For example, commodities which are necessities like medicine or food grains have relatively inelastic demand because people cannot do without them. Price changes are less likely to change the quantity demanded. While commodities which are luxuries like holidays in foreign countries, yacht travel, these are things for whom the demand is very responsive to prices. Similarly, for commodities having a lot of substitutes, we can expect demand to be elastic because any increase in the price of these commodities will make people shift to the substitute. Also, for a shorter time horizon, demand is typically inelastic when compared to a longer time horizon. This is simply because over a longer time period, people can find alternative commodities or simply learn to do without a commodity. So, if petrol prices become very high, one would expect that over a long time period, the decline in quantity demanded would be much larger than in the short run. Why? Over the long run, people could switch to other means of transport and companies could develop vehicles running on other fuels. To summarize what we have studied in this module, we've used the concept of the budget set and consumer preferences developed in earlier modules to understand demand and factors that affect demand. We then learned how to aggregate individual demand curves into a market demand curve. Finally, we looked at the responsiveness of demand to price changes through the concept of price elasticity of demand. Thank you.